Let's actually talk about a problem on the last quiz before we get started. When we did the last quiz, the homework that we had a problem where it had heights of people, and it gave you a set of data. So imagine that these dots up here are a set of data. And the problem that we had in the classwork, the assignment, the multiple choice assignment, said that one of the people's is actually 12 inches shorter, and then the median person is 12 inches taller. So, because you subtracted 12 and you added 12, the mean stayed the same, but what happened to your standard deviation? It increased because these numbers that were there, like this one, got 12 inches shorter, and so it moved farther away from the center. And this one, that was the median, moved 12 inches away from the center. Okay. All right. So getting farther away from the center, the standard deviation increased. All right. Now let's talk about a question that was on the quiz, because it was worded a little bit differently, and you needed to pay attention to the way it was worded because it changed the outcome. It wasn't just because things move around doesn't mean the variability increases. You have to pay attention to where the dots are going, where the data is going. So the one on the quiz said this. Took the shoe sizes of whatever group, and a mistake was made. And the lowest shoe size was actually supposed to be 3 inches, was 3 sizes too small. So the lowest shoe size was 3 sizes too small and should be higher, which is closer to the center. The biggest shoe size is too big, a mistake was made, and it should be 3 sizes smaller. It was 3 sizes too big. So the pieces of data that moved got closer to the center. So if you were to fix the mistakes, what would happen to the variability of it? It gets smaller. The variability gets smaller because the pieces that were messed up move in towards the center. Now, I ended up going back and rereading the question, since it was one that I had made up and written. The question I thought was ambiguous. It didn't really say, are you fixing it or are you looking at the mistakes? So I ended up giving credit for both increasing or decreasing on that, just because the way it was worded was ambiguous. But the moral of the story is, just because it's one thing on the homework or whatever, you still need to, it could be different on the quiz or on the AP test, and you need to pay attention to specifically what's happening. Just because something moves doesn't mean the variability increases. All right. Now, let's also talk about on page 40, last week, I said, let's save this number 16 for later. I said I need some pictures to kind of explain what's going on to you. So let's save that one for later. So I have got pictures now that were our notes from when we did that unit, and so I want to review that. So real quickly, here's some data. Here's the data set. And this is the original data. And the line that goes through them has a slope of 0.89 and a correlation of 0.987. Okay, because they're pretty strongly correlated to the line. So then, in this second section here, this point comes into play. Okay? The key to that point is that if you take a look at its location in comparison to the x values, see how it's pretty much in the middle of the x's? Okay. And then here's the center of the y's. So this is the mean point that's on the line. And this is pretty close to the center of the x's. So the key is this point is not affecting this line very much. In fact, the new line is drawn in there. You can't even tell it's much different than what was there. Do you see? Look at what's above. See, this is a single skinny line, and then this one down here looks thicker because it's two lines. Because this point added another line in there, and it hardly changed at all, right? So because this is close to this point is close to the center, the slope stayed about the same and didn't change. In fact, it's 0.87, so that's not a huge difference, only 2/100ths. But what happens to this point in terms of what does it do to the correlation of the data? Correlation was 0.987, and then with this point in here, it's 0.927. So it's out of whack, making the correlation do what? Go down. All right. Now, one final tidbit of information about this. On the AP exam and my tests and everything, I've always told you to be careful of the wording of the question. Do they say, add this point in? If they say add this point in, then it is making the correlation go down. But if they say remove this point, then it will make the correlation do what? Go up, okay? So pay attention to if they are adding the point in or if they are removing the point from the data set. So you know if that's making it go up or down. Okay, moving on to this one, let's see how this affects it. Do you see how this point is far away in the x direction? And it's also quite a bit out of whack, up and down. So it naturally, here's the original line, and this is naturally pulling down the line. Because here's the center of the data. Since this point is to the right of the center line, it's pulling it towards it on this right-hand side here. Okay, does it change the slope? What does it do to the slope? It makes it 0.19. It's less steep. Okay. How about the correlation? What is this whacked out point going to do to the correlation? It's going to really decrease it. So the correlation, in fact, is 0.24. So that really decreases it quite a bit from the original. Okay. Now this one's interesting. Look at this point. It is far out in the x direction. It's got high leverage there. But what's interesting about it? It's consistent with the rest of the data. So not only, it's gonna then, as far as the equation of our line, will it affect the slope? No. So it doesn't affect the slope. But how about correlation? What does it do to the correlation? It actually makes the correlation stronger. Because we're saying, hey, you know what? Actually, you tell me why. Why does it make it stronger? Because it's a whacked out point. It's way out there. Why is it making it stronger? Because it's in line with the rest of the data, and we're saying what it tells us then is, hey, guess what? Not only is our pattern linear in that section there, but the linearity continues all the way out to here. So the same linear pattern continues out further, so that is a stronger linear correlation. All right, and our final point here before we go to the problem we were going to do in your assignment we didn't go over last Friday. So here we have this point over here. Now let's reference, here's the center of the x's. So this point is to the left of that. Therefore, what's it going to do to this line? It's going to pull the back end up towards it. So it's going to pull the back end up towards it since it's to the left of the line, and that's what you see here. It pulled it up a little bit, so our slope actually did what? Decreased. Our slope became 0.55. It's less steep. Okay, how about the correlation? What's that guy right there going to do to the correlation from the original? Decrease the correlation. Correlation, 0.51. All right, now, finally, let's go back to this one that we said we were going to save for later, last Friday, and let's talk about it. I I believe that the center of the x's is right here. So this point, they add this point in. It says in the instructions, what effect does the point have on the data? So they add that point in. They don't remove it, they add it in there. So what is this going to do? It's to the left of the middle. So what's it going to do? A little bitty bit. It's going to pull this back end of the line up a tad. It's pretty close to the center, so I mean that's arguable. You know, how much this thing pulls it up is really arguable since it's pretty close to the center of the data. Okay? So the slope is going to change ever so slightly, and the slope will ever so slightly decrease. Okay? And if it's changing that slope, it's influential. Only if and when it's changing that slope. So the closer you are to the center, it's less influential. How about the correlation? Correlation. What does point do to the correlation? Decreases it because this point is out of whack, so it decreases it. All right. So I wanted to talk to you about that because we didn't get to last Friday, and there is a question regarding that on the quiz that you're going to be taking today, quiz part 2, multiple choice. So the last thing I want to do before I let you loose on the quiz is go over the homework that you had last night, which is the multiple choice on section 3. So here we go. So the multiple choice for section 3, actually we probably won't have too many questions on this, so it'll go pretty quickly. Here we go. Number 1 was D. Number 2, E. And number 3 is B. Number 4 is D. I kind of am thinking 3 might be a little true because if you're going to block, you got to like look at the, see if they're male or female so you can put them in the right place. But 2 and 3 was not an option, so I'm going with 2. 5 is C, and 6 is E, producing a representative sample. All right, now number 7 I thought was a debatable one, and you probably want to go with the best answer. So let's discuss this, especially since they included block design and matched pairs. Matched pairs is a type of blocked design. It's just more specific, gives more details. So for example, if you have adult dogs and you want to see the effects of a high-protein diet, okay, so tell me about qualities of dogs. Is there just like a bunch? You know, there's size, overweight, underweight, activity level. Is that breed prone to arthritis, not prone to arthritis? I mean, there's a bunch of qualities and traits in the dogs. So if you just did answer C, which says block, that pretty much just blocks on a trait. For example, large versus small adults. Okay? But I think there's more to the story of an adult dog than just large versus small. That could have an effect on the protein, how the protein affects the dog. I mean, see, I don't know. I'm not educated enough to know really what are they going for here. But matched pairs is a type of blocking, and it will control all of the traits. Okay, so if I want to do one that's best and I can block, then I might consider doing that. Okay, this one, number 8, is B. The wording, it will cost taxpayers $30 million in 30 years. Number 9, 1 and 3. So answer B. Okay, see this right here? Let's talk about that. In an experiment, you are assigning the subjects to a treatment to see if you can evoke a response or not. So in an experiment, you are seeing if you get a response. So when it says does not attempt, that's what's wrong with that. In an experiment, you are attempting to see if you can get a response. Number 10, so in an observational study, that's not the case because you aren't controlling everything. You're just currently there. So D is the answer for number 10. Number 11 is B. statistically significant, happens when the observed is too far away from expected. There's not really a chance, or wait, so hold on a second. There's not really a way that the sample I got happened because of chance. Because of chance. Okay, so it didn't just happen because of chance. It happened because it was way far away. Number 12 is A. 13 is B, 1 and 3. Number 14 is B, 1 and 3. Number 15 is A. Okay? Number 16 is C. This haphazard thing, that is not appropriate. That sounds randomized. That's not randomizing. Randomize is a predetermined randomization procedure. Haphazard, I could just say, you go there, you go there, you look like you should go over there. Well, I could have some kind of bias in doing such. So haphazard is not a way to describe randomness. All right, here's another one where completely randomized is just straight up in a big bag. And I am hoping that the process of randomization, so you know my little song, randomize to reduce bias, but when you need to spread unknown traits evenly, randomize. So I'm hoping to spread any of these unknown lurking variables, spread any traits evenly amongst the groups, I randomize. When you need to spread unknown traits evenly, randomize, randomize. Okay? So the purpose of blocking is to control confounding variables. Because if it's a medicine, or is it the gender? Which one is, is the testosterone affecting the medicine's effectiveness? So I need to control gender if I think that's an issue. All right. Experiment can determine cause and effect. Number 20 is A. Kind of actually already said that. We want to control. Number 21 is another one where matched pairs is best because we got the right side against the left side. So it's one person. And number 22 is statistically significant. And 23 is D. And the last one, 24, is blocking by a trait. You block by a trait. You do not block by a treatment. Both of these are treatments. And I will block because by a trait. I see you have a trait there that may affect the way subjects respond. Okay, now let's talk about your homework before we do the quiz because you're going to want to do part of it right after your quiz. So the way this is going to work is there are actually 3 free responses you will be doing. We have only done one so far a night. We did one last week and one over the weekend, but those were number 6s. These are all not number 6s, so they will take much less time. So I want you to do pages 61 to 65. That's 4 free responses, but go ahead and leave out this one on page 63. We'll just never do that one. So you will do 3 free responses. The key is this. These are not number 6s, so they should take less time. You need to time your free responses. I'm going to tell you right now, this first problem that you're going to do on page 61 and 62 is the lengthier of the 3. This one should take you 12 to 15 minutes. The other 2 should take you 8 to 10. Okay, so there's you a time frame to give yourself a good little guide. So after the quiz, take 12 to 15 minutes and do this first problem. See if you can't do that timed free RQ. All right, that's it. So let's